How to simplify an expression using order of operations. In this video, you will learn how to simplify an expression using order of operations. What are order of operations? It is a method that is used to simplify an expression. Simplifying an expression means to shorten an expression without changing the value of the expression. People across the world simplify expressions for various reasons. Order of operations serves as the universal set of rules to simplify expressions. Order of operations are needed and used in everyday life. They can help you calculate a sales price, the amount of money needed or saved, and determine the weight of a package. Here is a real-world application that requires us to use order of operations. A clothing store has a sign shown in the shop window. Penny wants to buy 3 shirts that each cost $12 and 2 pairs of jeans that each cost $19. Write and simplify the expression to find the amount Penny pays if a $3 discount is applied to her total. We will come back to this problem later in this video. What's the easiest way to remember the order of operations? Using the acronym PEMDAS. Each letter represents a different operation. We're going to work through each letter with an example. Let's talk about P. The P is for parentheses. This means to simplify any expressions that are inside of the grouping symbols. In this example, 11 minus 8 is in the grouping symbol called parentheses. We have to simplify this by subtracting 11 and 8, which is 3. The expression has now been simplified to 3 squared plus 3 times 6. Next in PEMDAS is E, which stands for exponents, which means simplify the terms with the exponent. Continuing from our example, 3 squared simplifies to 9. The expression has now been simplified to 9 plus 3 times 6. Next in PEMDAS is M and D, which stands for multiplication and division. It is important that you read the expression from left to right because you will need to do the operation that appears first in the expression. So in the case of our problem, 9 plus 3 times 6, only multiplication appears, so we will simplify this portion of the operation. 3 times 6 is 18. Our expression is now simplified to 9 plus 18. The final step to the order of operations is A and S for addition and or subtraction. Like the multiplication and division step, you will need to do the operation as it appears in the problem from left to right. In our example, we have to add 9 and 18 to get our final answer of 27. After applying the order of operations, the expression 11 minus 8 squared plus 3 times 6 simplifies to 27. Now back to our real-world application problem. Order of operations can be used to help us write and simplify the expression to find the amount Penny will have to pay if a $3 discount is applied to her total.
Based on the real-world application problem, the expression to represent it is 3 times 12 plus 2 times 19 minus 3, where the blue 3 in the beginning multiplied by the blue 12 represents the number of shirts and the cost per shirt in dollars. The green 2 and the green 19 represents the number of jeans multiplied by the cost per jeans in dollars. And the last red 3 subtracting from the expression represents the $3 taken off of the total price described by the store's sale. Using the same expression we retrieved from our problem, you will need to simplify it in order to find out how much Penny will spend in total at the store. Pause the video and simplify the expression. Do you receive a total of $719 or $71? If you received a total of $719, it is because you simplified the expression from left to right rather than using the order of operations. If you received a total of $71, it is because you successfully applied the order of operations. So how did we get a total of $71? If we follow the order of operations by using our newly learned acronym of PEMDAS, we notice that there is no p for parentheses and that there are no e for exponents in our expression. Moving down the acronym, we ask ourselves, do we have any m for multiplication or d for division within our expression? Yes, we have two sets of multiplication problems, which are 3 times 12 and 2 times 19. Because we have two sets of multiplication problems, according to the order of operations, we need to work on them as they appear from left to right, ignoring all other operations at this time. We will start on the left with 3 times 12. The best way to solve this is to show our work step by step, grouping what we are working on by using a down arrow underneath it. 3 times 12 is 36, and we will bring everything else down that we haven't used. Moving to the right, we will work on 2 times 19, as that is our next multiplication problem. 2 times 19 is 38. Our expression is now simplified as 36 plus 38 minus 3. We ask ourselves, do we have any A for addition or S for subtraction in our expression? Yes, we have both addition and subtraction, and according to the order of operations, we need to work on them as they appear from left to right. Starting from the left, we will add 36 plus 38, which gives us a sum of 74. We will bring down what we haven't used yet, which is the minus 3. Last but not least, 74 minus 3 gives us a difference of 71. We have come to a single number with no operations left over. Therefore, we have successfully simplified our expression. As always in math, we need to put our answer into a complete sentence when answering a word problem. Because we simplified our expression to 71, that means Penny will spend a total of $71 at the store during their sale. Let's recap what we have learned today. We use an important acronym to help us follow and apply the order of operations, and this acronym is PEMDAS. Each letter stands for a different operation that can be used in a mathematical expression. The P stands for parentheses, the E stands for exponents, the M and D stand for multiplication and division, and those must be worked together from left to right, and the A and S stand for addition and subtraction, and those must be worked together as well from left to right. These rules must be followed in order to successfully simplify a mathematical expression. Why do we need to use order of operations again? Well, to have a universal set of rules when simplifying an expression.